All right, now we're talking about the ellipse, and I'm going to assume you've at least seen some of this. Maybe it was in a video I posted, but you've at least seen a little bit of the ellipse. Basically, the equation that starts most of this off is x squared over a squared plus y squared over b squared equals 1. And if you did see this in an earlier class, Algebra 1 or Algebra 2, you were done pretty quickly. In this class, they ask you more things than just the graph. So when they say analyze an ellipse, it's not immediately clear what that means. Analyze means they want you to find what they call the vertex, the foci. If there's a center, find the center. So there's a little bit more than just drawing the picture. What is an ellipse? What an ellipse is, you take 2 points, focus 1 and focus 2, so 2, plural of that is foci. And what they're saying is, we want to be equally distant from both points. No, we want to be, that's the parabola. And it's not with 2 points. We want the distance from the 2 points to be a fixed amount. So whatever the total distance was for that point, there's another point over here maybe that has the same total distance. It might be a little farther from one, but it's also closer to the other. And they even say a good way to imagine this or to draw it is to take 2 pins and a string, and that string won't change its length. So the string, the total length of the string, is constant, and that gives you an image of an ellipse and tells you the role of the 2 foci. And that's probably the big story here is just drawing something like this really is an Algebra 1 skill, and it's kind of done. But they throw in this stuff about the foci and specifying what is the vertex or the each of the vertices. So that's going to take a little bit of thinking or a little bit of work. So did I see this? Okay. So I'm not really going to focus in on this one too long because that's not the only formula here. So let me write a formula you know. You know this formula, a squared plus b squared equals c squared. And how does it work? This is the formula for a completely different a, b, and c. It's the formula for a right triangle where c is the hypotenuse. C is the largest one. That is geometrically and physically impossible in this case. In the case of the C that we're talking about. C cannot be the longest one because C is just this little distance here. So look, if I go past C to the vertex, in this case A is clearly much bigger than C. So why do I say it that way? Well, the biggest one goes there. So I could have a squared plus c squared equals b squared if b is the largest one. But I could also have b squared plus c squared equals a squared if a is the largest one. So they gave us this one. A little hard to tell because of the way they arranged it. They didn't solve it they didn't use a plus. But let me cross this one out. For the ellipse, you cannot have a squared plus b squared equals c squared. That's impossible. But you can have the other 2 equals b squared, the other 2 equals a squared. Just depends on which one's the biggest number that you physically see with your eyes when the problem is written here. In other words, a could be the biggest number, b could be the biggest number, and You can see how A, B, and C are related. All right. I want to emphasize that more than it needs to be. Choose the formula that works. Actually, I'm going to skip through this example, I think. Yeah. And let's look at example 2. All right. So A is what's under the x. So let me write the formula here. It's x squared over A squared plus y squared over B squared. So this is perfectly correct. A squared is 25. B squared is 16. So if this were algebra, I keep on saying algebra 1. I'll say algebra 2. I have the center because there's no HK. I'd go 5 this way because it's 5 squared under the x. I'd go 4 this way because I can think of 16 as 4 squared. And that would be the end of it if this were algebra 2. But it's college algebra. We're amping this up a little bit. So let's skip down to, by the way, I know what the biggest thing squared is, right? B squared is not the biggest one. It's 16. A squared is the biggest one. It's 25. So what was it? It's not, it's going to be equals A squared. The formula is going to be B squared plus C squared equals A squared. And I might use this to find C. C is the one thing that's invisible to me, so we'll find it. All right. Let's look at the picture. All right, so this is the first part, what I had already. If I go 5 this way and 5 this way, now we call these the vertices because this is not a vertex. On the 4 is the shorter distance. It's the longer distance that gets the title of vertex. So vertex 1, vertex 2. If they ask you for the vertex, it's because of the 5 squared here, and I want to add 5 and subtract 5. This they might ask in a different way, but they won't ask for the vertex. Now, how do I find the foci? Well, let me write down the formula. However you write it down, we know that it's A squared equals B squared plus C squared. At least I'm going to write it this way. I know that A is the bigger one. So I get A squared minus B squared equals C squared. And let's substitute it. I already know what A squared is. I mean, I don't even need to think about what A is. A squared is 25. B squared is 16. And that equals C squared. So 9 equals C squared. So what's C? Well, it's okay to say C squared is 9. It's okay to say C is 3 because you can think of it as a measurement. But I'm going to write it as plus or minus 3. Just so you can understand that if I take this, I'm going to go 3 in each direction. So 3 this way and 3 that way. What do the foci do to the image? It just kind of enhances the image. It's not really, like I say, something you add in any other algebra class. But once you get to this level or higher, yeah, we want to know where the foci are along that same long part of it that gives you the vertices. So by the way, this piece, this long piece, that right here, we call it the major axis. And the major axis is just a longer one. This could be called the minor axis, but it's a longer one. All right. So they give us another formula, yet another formula. I don't know. Not a fan of those boutique formulas. you know, the formula just has one kind of piece to it. Let's look at this. We have this equation. We want a 1 here, so it makes sense to divide everything by 16. If you do that, you have this, but keep in mind there's an invisible 1 sitting under the x. So a squared is 1. Trying to see if they're calling a the larger number. Oh man, not used to this. All right. They switched a and b around. They didn't just leave the letter a under the b under the x. All right. So the author is essentially saying a is the larger one. I'm used to this with the hyperbola, but not with the ellipse. So not every book will do that. But all right. So back to this. All right. Since this is the bigger one, not because it's under the letter, but because this is the bigger one in this case, that's my a squared. This is my b squared, 1. So doing the calculation, the big one minus the smaller one, I get c squared is 15. So c is going to equal, well, we'll just think of it as plus or minus the square root of 15. So if that's true, I have the entire graph, and I had most of it even before this started. Remember what it was, x squared over 1 or 1 squared plus y squared over 16 equals 1. As soon as I have that, I can think of it as x squared over 1 squared, y squared over 4 squared equals 1. So along the y-axis, I'm going to go 4. Along the x-axis, I'm going to go 1. Draw an ellipse through there. And where are the foci? Well, this is correct. If I take the larger of these, 16, minus the smaller one, 1, that's equal to c squared. So 15 equals c squared. And so we can think of c as equaling the square root of 15. So I go square root of 15 in one direction, square root of 15 in the other direction. They didn't really calculate square root of 15, but I kind of know. A square root of 16 is, of course, 4. So the square root of 15 is a little less than 4. But just so you could kind of see what those points look like, you might get that. So this time they're asking us to find the equation of a graph. So again, something like this, definitely draw it. I can't imagine doing all of this work before getting anything inked on the page. So they're telling us that one of the foci, one focus at 0, 3, and then they give us the vertices. All right. So they gave us the one focus and these two vertices here. So basically, we know what C is, and we know what A is. What we don't know is what B is. So if C is 3, that means C squared is equal to 9. If A is 4, that means A squared equals 16. And put that into the formula, because we know A, 16, A squared, 16. We know B squared is 9, or C squared is 9. So what do we have? B squared equals 16 minus 9, or B squared equals 7. So if B squared equals 7, this distance is the square root of 7. Didn't try that on a calculator, but you know, it's less than the square root of 9, so it's between 2 and 3. All right. And all of those values are good. And then just knowing that B squared equals 7 means I'm going to put the B squared here. And again, they're not connecting. Some books would call the number under the x A, not like A squared, not B squared. But the author is saying The larger one is a squared. The smaller one is b squared. So it would be correct to call that b. All right. What if your parabola is not centered at 0, 0, but centered at h comma k? Well, it's that same thing that we've been doing every single time. Parentheses x minus h squared, parentheses y minus k squared. Everything else is really the same. So let's look at a fairly complicated problem. All right. So in this problem, they had just told us that the center was 1, 2. So h is -1, k is 2. Then they gave us the focus and the vertex. Let's see, -3, 2. All right. So first things first, draw the picture. There's my center. They gave us, this is the focus they gave us. So if there's a focus 1, 2 in that direction, C is 2. And if there's a focus in that direction, it has to be a focus in this direction. So I could plot that to find that point. Now what else did they tell us? That there is a vertex at -5, 2. I believe that's the one they gave us. Where was the question? I did a lot of work on this problem. Yeah, no, it was, yeah, -5, 2. Okay, just wanted to see what they gave us. So basically you'd plot this point, and that point. And then you just look at it, and since they called that a vertex, this distance is A. So A is 1, 2, 3, 4. So let's write down what I know. I know H, just was given to me, is -1. I know K is 2, just handed to me because they told us that. From looking at the distance, I know that C is equal to 2, so that means C squared is equal to 4 when I need it. I know A is equal to 4, so that means A squared is equal to 16 when I need it. So the only thing I don't know right now is B, and I'll come up with that, but I have most of this formula. I have x minus a -1 squared over A squared, which is 16, plus y minus k, so y minus 2 squared, over B squared. And that's the one thing I don't have is B squared. I don't know what that is yet because I haven't run that calculation. But the calculation is just, A squared is going to be the bigger one. So the calculation is A squared equals the sum of the other two, B squared plus C squared. So A squared is 16, B squared I don't know, and C squared is 4. So I'm going to get B squared, if I subtract 4 from both sides, is 12. So that's the 12 I can put right here. I don't really need to know what B is to draw to do this, because it's B squared that I want right there. But what is B? Well, B is the square root of 12. So I'm just going to go up the square root of 12, down the square root of 12. Now that gives me a very interesting ordered pair here. I know that I'm at -1, comma 2. But if I go up square root of 2, notice how the math works out. I have 2 plus, well, I said square root of 2, 2 square root of 3, which is the simplification for the square root of 12. So I have 2 plus the square root of 12, simplified, 2 minus the square root of 12 in a simplified form. But that's only if I wanted to find these ordered pairs. It doesn't really change the equation at all, but it gives me a lot to work on something